video lecture we are going to study work, energy and this video lecture we are going to study work, energy and power. What is work? Everything we do is called work done. Means what? Means what? Force causing displacement is called work done. Is called work done. So you write W equals F dot S. So you write W equals F dot S and which equals Fs cos theta, which is nothing but work done. And what is energy? Energy is the capacity to do work. It is having two types: potential energy. It is having two types: potential energy and kinetic energy. Potential energy is nothing but energy acquired by an object during rest at height potential energy. So we can write potential energy is nothing but mg, because mg is the force multiplied perpendicular distance is called the force multiplied distance, or the displacement is called the work done. So in this way mg at height h is called the potential energy acquired through this object. Then what is kinetic energy? This is the energy acquired by an object during motion. So this I can write down a velocity v, then kinetic energy is nothing but half mg square, and work and the energy both are having the units joules. Here we can write down kilogram meter per second multiplied meter, so kilogram meter square per kilogram. It is nothing but kilogram and meter per second square. So here second square will be kilogram meter square per second square is nothing but the unit of work done, which is again equal for the energy also, which is joule, and power is nothing but rate of doing the work done. Work done varies with respect to time. This work done varies with respect to time. So we can write this as power, which has the unit kilowatt or watt. Okay. Now we will prove one relation which is called the energy equation mgh, which is called the energy equation always constant. Energy is always constant for an object. How to do this? See here. Object. How to do this? See here, this is object at point A, and this is the ground level height A from the ground level, which is having height h from the ground level, reach an intermediate station B with height y, hovering with velocity v or c. This will be u and final velocity after reaching will be v. Okay. And this means y means this will be simply h subtract y. So the energy acquired at A will be simply potential energy, because this is at rest position. So we know potential energy is nothing but mg multiplied the height h. So at A point total energy will be mgh. Similarly, at point B is from A. For example, this top, say the object released from A. For example, this top release, this is at A point, this reaches to B point, and after reaching B, the object is rest condition. So I can write here the energy acquired through this top or this object will be first kinetic energy covering y distance at u velocity and potential energy after reaching B point. So kinetic energy from A to B and potential energy after reaching B point. So how we will write this half m u square plus potential energy will be simply mg h subtract y, because at height h we are finding mgh. At height h subtract y, mg h subtract y we can write. And see, this is not equal with this. So we will put here our equation of motion v square equals u square plus 2s, because this is motion under gravity or gravitational pull of attraction. A will be simply equals with v. So putting here A will be, so v square equals u square plus 2vs, yes or no? Then after reaching B point, the velocity v equals 0. So we can write the v value is 0, which equals u square plus 2gs. Okay. And this equation needs u square, see the relation exists here, u square divide 2 equals gs, and your negative sign vanishes because gravitational pull of attraction generates deceleration in the object. So negative sign is for deceleration of the object. So I can write half u square equals gs. Now putting this gs equals half u square, we will write here this equation get converted. Half u square multiplied m plus mg multiplied s subtract y equals m multiplied gs plus mg h subtract mgy. But see here, the distance covered, the s is equal to u, y here. So I can write here, because the object is covering y distance, then only reaching B point. So I can put here in place of s, y will be put. So mgy plus mgh subtract mgy. So cancelling mgy positive negative value, simply we are getting mgh, which is at point B. At A point we are getting mgh, and B point also we are getting mgh. After crossing B point, the object reaches to the ground which touches at point C with velocity v. So I can write half mv square the kinetic energy and the potential energy equals 0 because height is 0 here. Okay. Zero value kinetic energy equals half mv square. So potential energy get zero value, kinetic energy equals half mv square. And we know kinetic energy is equal to potential energy. So from this we can find half mv square equals mgh. Cancelling m from both sides, I can write v square equals 2gh. So v equals root over 2gh, and in case of c we are having total energies in place of c we can write simply half mv square because our potential energy is 0, kinetic is half mv square, and this equals half m multiplied v square value will be root over 2gh square. So half m multiplied this value will be after squaring 2gh, so 2 get cancelled. Finally mgh at C point of an object. So hence proof the total energy of an object is always constant, which is equal to mgh. Thank you.